Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today we will be solving the problem kth permutation sequence from the SDE sheet. But before moving on to the problem, if you are new to our channel, please do consider subscribing to our channel. So the problem states that you'll be given a value n and you'll be given a value k. So if you're given n, so the set will be 1, 2, 3 up till n. And any set which is containing n numbers is going to contain exactly n permutations, exactly n factorial permutations, right? So just imagine if n is given as 3. So can I say this is going to have 3 factorial permutations, which is 6 permutations? So all the 6 permutations are written over here if you carefully observe. Now if k is given as 3, so you got to tell the third permutation, which is 2, 1, 3. If k is given as 5, you're going to tell the fifth permutation. So the question is very straightforward. You will be given a value n. So, for every n, there will be n factorial unique permutations. And if you sort them, right, if you write them in lexicographical order, you need to return the kth permutation among all the n factorial permutations. So this is the question that you need to solve. So obviously, if this question comes up in the interview, what will be your first approach? The first approach should be brute force, yes, where you tell the interviewer that you're going to use the recursive way to generate all the permutations, right? So you can use the recursion. So I'll not be telling you the recursion code, but I'm just telling you the brute force. So use recursion to generate all the permutations. So once all the permutations are generated, so that will be into some data structure. So what you need to do is you need to sort this data structure. So simply sort this data structure. Once you have sorted this data structure, I can surely say that the kth permutation will be at the k minus 1th index, assuming that the data structure is storing all the permutations in the zero based indexing order. So I can say the kth permutation will lie at the k minus 1th index. So this will be the brute force that you're going to tell the interviewer, that you're going to write a recursive code. In most of the cases, the interviewer will never ask you to write the recursive code because the recursion is not the solution for this question. So he will just ask you what will be the time complexity of recursion and all about that. So you're going to tell him that it will be n factorial because you're going to generate all the permutation. So the recursion is going to take n factorial time, and obviously you're going to make a deep copy of every permutation that you generate to put it into this data structure. So the deep copy is going to take a big O of n time. So the total time of the recursion will be n factorial into n. So that will be the time that recursion is taking. After that, you have to again perform a sort, right? So if there are n factorial list, so it's gonna take n factorial time, n factorial log n factorial time to sort. So it's gonna take a lot of time to sort. So this is what you're gonna tell the interviewer. Now this is the moment where the interviewer will interrupt you generally and will tell you that this is taking a hell lot of a time and you need to improve the time complexity. And this is where you're gonna jump into your optimal solution, right? Don't jump straight away into the optimal solution, because in an interview it's a process. You start off with the naive solution, then only you move to the optimal solution. So when the interviewer will interrupt and tell you to optimize this, that is the moment you present him with the optimal solution. So let's discuss the optimal solution now. So if n is given as 4, right? So we know that there are 24 permutations because that is 4 factorial. So there are 24 permutations. So if I am looking to find k equal to 17 permutation, let's look into this mathematically. So I know the set is going to contain the numbers 1, 2, 3 and 4. Okay, so if I just pick up the number 1 and I say the other numbers are 2, 3 and 4, right? So if I say this, that means I'm starting the permutation with 1. Now what if I say let's start the permutation with 2? So I can say the rest of the numbers will be 1, 3, 4. Now what if I say let's start the permutation with the number 3? So the rest of the numbers will be 1, 2, 4. Now let's say we're going to start the permutation with the number 4. So the rest of the numbers will be 1, 2 and 3. So I can either start the permutation with 1, or either I can start with 2, or either I can start with 3, or either I can start with 4. So can I say the number of permutations that will start with 1 will be 6. The number of permutations that will start with 2 will again be 6. The number of permutations that will start with 3 will be 6. The number of permutations that will start with 4 again will be 6. Now why can I say that? Because these are three numbers and they will permute in themselves. So if three numbers do permute in themselves, they're going to take 3 factorial, and that is nothing but equivalent to 6. So basically 6 plus 6 plus 6 plus 6 is going to give you 24 unique permutations. That is your total number of permutations, right? So now let's look it into mathematically, right? So I'm saying that I require 17, right? I require 17. So at first, let's put all these numbers into some data structure. So the data structure will have 1 at the 0th index. This will be at the first index. This will be at the second index. This will be at the third index. Now I can say that I'm gonna mark all the unique permutations in 0 based indexing, right? So if the first permutation is 1, 2, 3, 4, while the last is 4, 3, 2, 1, that's the first and last. So I'm gonna call it the 0th permutation, while I'll call this the 20th permutation. So I'm gonna mark the permutations by 0 based indexing numbers. So in that way I can say this permutation will be containing 0 to 5 in 0 based numbers. This is gonna contain 6 to 11 permutations. This is gonna contain 12 to 17 permutations. This is gonna contain 18 to 23 permutations. I can assuredly say that, right? So if the question is stating to find the 17th permutation, so what I can say is I'm actually looking for the 16th permutation, because I have taken everything in 0 based indexing. So I'll be looking for the 16th permutation instead of looking for the 17th permutation, right? So if I ask you a simple question, if k is 16 in terms of 0 based indexing, so which will be the first number in your 16th permutation? So can I say the first number will be 3, because in this range is where 16th permutation will lie. So I can easily say if they're containing 6 numbers for every range, right? Every range is containing 6 numbers. So 16 by 6 is nothing but 2. So if I'm considering 0 based indexing, so the number at the second is nothing but 3, right? 0, 1, 2. So at the second index, I have a number 3. So I can surely say that my permutation starts with the number 3. So I have got the number with which my permutation starts. So what I can say is, since I've got 16, so I can say 12 numbers have been taken, because 6 plus 6, 12 numbers I have jumped. So now I can surely say that my sequence is lying in between this. So how many numbers are over here? So the number of sequences in this range is 6. And out of these 6 sequences, I actually have to find 16 modulo 6, that is 4. The 4th sequence out of this 6 sequence. If I'm able to find this, I think my job will be done, right? So let's move into the next step, where I'm trying to find the 4th sequence. So I did boil down the question. You need to understand. Now the question has been boiled down. You just have to figure out which is the 4th sequence among these 6 sequences. So can I say the set of numbers remaining, if you have picked up 3, will be 1, 2, 4. So all the permutations generated among these, you just have to figure out which is the 4th permutation sequence among these permutations, right? So let's do it. So since the question has boiled down to the list of numbers as 1 to 4 and finding the 4th permutation among all the permutations generated by this list. So let's follow the same process again. So if I say my permutation is going to start with 1, I can again say my permutation is going to start with 2. I can again say my permutation is going to start with 4. So if they're starting with this, I can say that the rest numbers are 2, 4 over here. The rest numbers over here are 1, 4, while the rest numbers over here are 1, 2. So if there are two numbers, can I say this is going to generate two permutations? This is also going to generate two permutations. This is also going to generate two permutations, which makes a total of 6 permutation. Again, if there are 3 numbers, the total permutation generated will be 3 factorial, that's 6. So we have figured them out into ranges. So I know this is going to be from 0 to 1, the 0th permutation and the first permutation. This is from 2 to 3, saying the second permutation and the third permutation. This is going to be from 4 to 5, saying the fourth permutation and the fifth permutation. So since k is 4, can I say, since I know every one is having 2, right, everyone is having 2 permutations, let's divide it by 2. So I can say my permutation will actually lie in this second. This is the 0th one, this is the first guy, this is the second guy. So I can easily say my permutation is gonna start with 4 right next. So I figured out the next number, that is 4. So the permutation is starting with 4. Again, does make sense because the 4 is lying in the range 4 to 5. So if you simply divide it, you will get which is the number where it is starting. So since I have figured out, that 4 is the next number. So what will be the value of k left? So again, you're going to do a 4 modulo 2. So when you do a 4 modulo 2, it says 0, right? That means the question now boils down that you have a set of 1, 2, right? Because you have already taken 3, 4. And now you have to figure out the 0th sequence. Yes, the 0th permutation among all the permutations generated by 1, 2. So let's do that. So I can say again the same procedure, that my permutation is going to start with 1 or my permutation can start with 2. So if my permutation starts with 1, I will be left off with 2, or if my permutation starts with 2, I'll be left off with 1. So this will be 1 factorial. So I can say this will contribute to 1 permutation, this will contribute to 1 permutation, and a total of 2 permutations. Again, it does make sense because if n is 2, I know the number of permutation will be 2 factorial, which is nothing but 2 itself. So this will be the range 0 to 0 permutations, and this will be the range from first to first permutation. So if you're looking for k equal to 0, you can simply divide it. I know every range is having 1. So if you divide it by 1, you get it as 0. So since you got 0, you can easily say that this block is the block which will contain your permutation. That means the permutation should start with 1. So you can pick that 1 and you can say that that is your third number. Now since you have picked up 0, right, you have picked up the 0th permutation. Again, you look for the remaining, that is 0 modulo 0. So again, you're looking for the 0th permutation at the next. So the next value of k will be 0. So can I now say that your list is now containing only 2 and you're looking for the 0th permutation among 2? Yes. So if you again follow the same process, I can say I will have the permutation starting with 2, but right now I don't have anything left. Yes, this is the moment you don't have anything left. So you don't need to figure out anything. Just pick out the remaining number and you tell this is going to be my last number. And this is how you can easily figure out your permutation without doing recursion. So it's very simple, guys. So this is how you are going to solve this problem. So if I summarize this, initially you had 4, right? And you know there will be 4 factorial, that is 24 permutations. So at first you divided it into 6 blocks of 6. And then figured out where does 16 lie. So you figured out 16 lies over here. Then what you did was you did a 16 modulo 6, the remaining number, that's 4. So now out of the 6, at the next stage, you figured out where does the fourth sequence lies in this 6. So in the next block, what happened was you took blocks of 2, then you took blocks of 2, then you took blocks of 2. And out of these, you figured out where does this fourth sequence lie. And you figured out that the fourth will obviously lie over here, because this will be 0 to 1, this will be 2 to 3, and this will be 4 to 5. So did you observe something? This was 4 factorial. So the next is 3 factorial, which is 6. So you're dividing it into 6 blocks. Next is 2 factorial, which is 2. Then you divide it into 2 blocks. The next step, you did divide it into blocks of size 1, if you remember. So the next was 1 factorial. So basically, it's a factorial stuff that you're doing. You're just figuring out where does k lie in which block, and whichever block it lies, you're just picking out that number in itself, right? You just pick up that number in itself. Like over here, there was 16, so k was 16 by 6. So that was basically the second block. So you figured out the third number is what you're going to pick up. Over here, k was 2. So the second number was 4. So you picked up 4. Over here, k was 0. So the 0th number was 1. So you picked up 1. Over here, again, k was 0. And the 0th number was 2. So you picked up 2. So at first 3, then 4, then 1, then 2. So that's how you're going to pick up. So I hope you have understood the mathematical part. It's just the implementation part that will be worrying you. So I'll be showing you the code, so don't worry about that. Once you see the code, you'll have much more clarity about the implementation as well. So what is the time complexity? So can I say if n is 4, I'm actually looking for the 4 numbers that will be in your permutations. So that's going to take a big O of n for sure, because you're looking for 4 numbers. So that's a big O of n for sure. And remember, whenever you picked up 3, the set did reduce to 1, 2, 4. And then you again splitted them into blocks. So you're basically taking this 3 out. The next step, you're taking this 4 out to get this set. The next step, you're taking this 1 out to get this set. So this taking out is taking big O of n, because even if you use erase functions do take a big O of n time if you're wanting to erase any middle element. So the time complexity will be big O of n square, and the space complexity will be big O of n again, because you're using this vector, and also you have to store this answer, right? You have to store this answer that you will be returning. So the space complexity will be big O of n. So this will be the time complexity and space complexity. Now it's time to discuss the C++ as well as the Java code. So let's discuss the C++ code. So what we can see is you're given the n and you're given the k, and if you return a string which will be the kth permutation for the given value n. So what did we require initially? We required something as 3 factorial, because we know the first division was in terms of blocks, and we also required array which will be having all the numbers. So that is what we do over here. We compute factorial 3. If n is 4, that means n minus 1 factorial is computed, and all the numbers from 1 to n are being stored if you take this line into account. So initially we compute 3 factorial or n minus 1 factorial, and we store all the numbers in the array. So this step is done, and you have computed 6, right? What is the next step? You know, if k is 17, now since our logic will be running on 0 based indexing, so let's reduce k by a value 1. So we reduced k by a value 1. So k becomes k minus 1. And we are initializing a string with empty, so that it can store your ultimate answer, that's 3412. Right at the beginning, what did we do? We know we will have blocks of size 6, right? Everyone knows we are going to have a block of size 6. So what we do is we basically make sure that 16 by 6 is done. So whatever is the number 2, so let's pick the number over here, that's 3. So that is what we do over here. You just pick that number, convert it into a character, that is 3, and add it to our answer. So 3 gets added to your answer. Right after that, you need to erase 3. So that is what we do over here. We erase 3. And k by factorial, that means k is 16 and factorial is 6 as of now. So that is done. Now once this is done, you're going to keep on doing this unless and until your list, this 2 is taken, and at the next step your list becomes empty. You're going to keep on doing this. So we keep on doing this. What will be the next value of k? Obviously it's going to be 16 modulo 6, that's 4. That's going to be the next value of k. So that is what we do. K equal to k modulo fact. What will be the next factorial? The next time the blocks will be of size 2, isn't it? 1 factorial less. So that's what you do. Just divide it by the size, because the size now will be 3. So if you're looking for 2 factorial, just divide 6 by 3 and you'll get the 2 factorial. So this is what will be going on for every step. You can keep on doing this till you haven't picked up every number from this array. Once you have picked up every number from this array, you will have your answer string stored as 3412, which you can return as an answer. So this will be your C++ code. So let's discuss the Java solution for this problem. So initially you're given n and k, for which you have to find the kth permutation, and they're wanting you to return a string which should be having the kth permutation. So initially what we do is we take a variable factorial and we compute n minus 1 factorial. Why? Because if n was 4, so the first block was of a size 6, so that's nothing but n minus 1 factorial. So the first block will be of size 6, so that is what we compute. And we're also making this array of size 4, which is going to store all the numbers 1, 2, 3, 4. So we store all the numbers from 1, 2, 3 and then the 4 over here. So all the numbers are stored. Now we need to return the answer in a string. So we declare a string array which is empty, right? After that, we are subtracting k by 1, because in our logic we are considering zero based indexing logic to solve. So if they're asking us to find 17 permutation, right, so we will be finding the 16 permutation. That's why I reduced the value of k by 1 to make it 16. Right after that, we're going to run an infinite loop. Till when? Till this doesn't becomes 0, because at the last step when you pick up 2, the list will be empty at the last step. So you're going to keep on doing till the list is not empty, right? So that's why I run a true loop. So basically at the next step, what you do, you're basically considering k by factorial. What's k? That's 16. 16 by 6 is 2, and this is your first number of your permutation. So basically pick out the second index number, which is 3. So that's what you have done. Numbers.get 3, and you attach it to your answer. So your answer will have 3 at the first step. Right after that, you remove this 3. That is what you have done. You have removed this 3 to get the new array, which is 1, 2, 4. So let's remove it. After this, if the list is empty, you break out, or else you keep on doing this. Now at the next step, k will be done a modulo of factorial. Why? Because you want the next value of k, that's 4. And how do you get 4? 16 modulo 6, because that's the remaining amount. So that is why you do a modulo. What about your next factorial? The first time the blocks were of size 6, right? But the next time the blocks will become of size 2, which means a factorial less. So you're looking for 2 factorial. So if I divide 6 by 3, where 3 is nothing but the size of this new list, I'll actually get 2 factorial. So that is what I've done. I've reduced the factorial at every step. You're going to keep on doing this task every time, and you will get your new numbers. Like you'll get a 4 over here for the next time, then you'll get a 1 over here for the next time, then you'll get a 2 over here for the next time. And the moment you get 2, you're gonna erase, you're gonna remove, and the moment you remove, the list will become empty and this will break out. Once this breaks out, you can return your answer, which is going to store 3412 as your 17th sequence for this example that I showed. So this will be it for your Java code. So guys, if you have understood the entire explanation as well as the code, please make sure you like this video, and if you're new to our channel, do not forget to subscribe to this channel. With this, I'll be wrapping up this video. Let's meet in some other video where we will be discussing some other problem from the SDE sheet.